Hello everyone. This is an A-level revision video of a series where I discuss past papers and model questions every week to prep for exams. Many of these questions are relevant for high school maths qualifications around the world like AP and HSC. For detailed explanation, I have made topic-based theory and question videos. You can check them out on my channel. Question number 1. You have to differentiate this function y equal ln ex plus x over ex minus x. Remind this, if you have y equal ln f of x, according to the chain rule, we can differentiate this function dy by dx equal to 1 over f of x times derivative of function f of x. In this function, f of x is equal to ex plus x over ex minus x. Now you can differentiate this function. You can write dy by dx equal to 1 over this function times derivative of this function. When you take 1 over this function, you can write it as ex minus x over ex plus x. Now you have to differentiate this function here. So you have to use quotient rule. According to quotient rule, it's ex minus x times derivative of this function minus this function times derivative of this function over square of ex minus x. You can simplify this fraction. First, expand this bracket here and this double bracket here. Take away, expand these two brackets over e to the power x minus x square. Simplify this expression. This term cancel out to this term. This minus x cancel out to this minus x. That would give you 2e to the power x minus 2x e to the power x over e to the power x minus x square. You can divide numerator and denominator by ex minus x. That's equal to 2e to the power x minus 2x e to the power x over e to the power x plus x times e to the power x minus x. You can factorize numerator and denominator. You have difference of squares. Therefore, we can write this as 2e to the power x times 1 minus x over e to the power 2x minus x square. Question number 2. You have to evaluate this integral. I'm going to write this integral as I, and 1 over x square you can write as x to the power minus 2. Therefore, you can write I equal to integral 2 to 3 x to the power minus 2 ln x dx. To find this integral, you have to use integration by parts method. Remind, if you have integration u dv, you can write this as uv minus integration of v du. When you integrate with limits, you have to substitute limit here and you have to integrate with this limit. Now what you have to do, you have to write this integration as u dv. 2 to 3 u dv. We need to find u and dv. When you have ln x, always you have to take ln x as u. Therefore, x to the power minus 2 dx you can write as dv. You need function v. You can integrate this. That would give you v as minus 1 over x. And you need du. Therefore, you have to differentiate this function du equal to 1 over x dx. Now I'm going to substitute u as ln x and v as minus 1 over x. Therefore, integration I equal to 2 to 3 ln x d minus 1 over x. So this is u, this is v. According to this formula, you can write now u dv equal to uv, that's minus 1 over x ln x. Substitute this limit minus v du. We have v minus 1 over x du is 1 over x dx. Limit is 2 to 3. This equal to, here you have minus 1 over x square. You can write it as minus x to the power minus 2. If you times it by minus 1, you're going to get plus integration 2 to 3 x to the power minus 2 dx. Integrate this function, it's minus 1 over x. Substitute this limit 2 to 3. Now you can substitute this limit to this function. You can bring this number as a power here and this number as power here. When you simplify this, you would get 1 over 6. If you want, you can write this as a single logarithm. ln 2 to the power half over 3 to the power 1 over 3 plus 1 over 6. Question number 3. Here you have graph of function f of x where x is a real number. Part A, you have to show that derivative of this function f of x equal to this function. Let's see how we can differentiate this function. Here you have product of two functions. Therefore, you have to use the product rule to find derivative of function f of x. F prime x equal to 4 times x square minus 2, differentiate e to the power f prime x equal to 4x square minus 2 times derivative of e to the power minus 2x, that's e to the power minus 2x times minus 2, plus e to the power minus 2x. Now differentiate this function, that would give us 8x. You can write this as minus 8x square minus 2 times e to the power minus 2x plus 8x e to the power minus 2x. Now you can take 8 e to the power minus 2x out. Thus gives us in the bracket as minus x square plus 2 plus x. Now you have this result here. If you want, we can rearrange this expression into this form. Part B, they ask you to find in simplest form the exact coordinate at the stationary point of curve C. So you can see here we have a stationary point and here also you have a stationary point. So we have to find coordinate at this point and coordinate at this point. At its stationary point, f prime x equal to 0. Therefore, this equation should be equal to 0. When you solve this equation, you would get x coordinate at this point and at this point. You can divide this equation by constant 8 and e to the power minus 2x never going to be equal to 0. Therefore, we can say that 2 plus x minus x square should be equal to 0. You can factorize left hand side, that's 1 plus x times 2 minus x equal to 0. Then solution to this equation is x equal to minus 1 or x equal to 2. Therefore, we can write x coordinate at this point as minus 1 and x coordinate at this point as 2. To find y coordinate at these 2 points, you can substitute x equal minus 1 and x equal 2 into the function f of x. Substitute x equal minus 1. This gives you f of minus 1 equal to minus 4 e to the power 2. Now substitute x equal to, that is equal to 8 e to the power minus 4. So y coordinate at this point is minus 4e square and y coordinate at this point is 8e to the power minus 4. Therefore, we can write stationary points as minus 1 minus 4e square and 2 8e to the power minus 4. And they gives you two functions g and h. G of x equal to 2 times f of x. X is a real number. G of x equal to 2f of x minus 3 and domain is x greater than equal to 0. So we need to be careful with this domain. They ask you to find range of g and the range of h. Let's see how you can find range of function g of x. G of x equal to 2 times f of x. Therefore, if you know the range of f of x, range of g of x is twice that range of f of x. To find range of f of x, you can use the graph of f of x. When x is a real number, range of f of x you can get from here. This is the range. Range of f of x is f of x greater than equal to minus 4 e square. So you can write range of f of x when x is a real number, that is f of x greater than equal to minus 4 e square. Therefore, now you can write range of g of x when x is a real number, that is g of x greater than equal to 2 times minus 4 e square. That's g of x greater than equal to minus 8 e square. This is the range of g of x. To find range of g of x, we need to know the range of f of x when x is positive. When x is greater than equal to 0, we can take the range of f of x. You can see it from here. This is the range of f of x when x is greater than equal to 0. Therefore, to get this range, we need the coordinate at this point. To find coordinate at this point, you can substitute x equals 0 into function f of x. Substitute x equals 0. This is equal to minus 8. So coordinate at this point is minus 8. Therefore, you can write the range of f of x when x is greater than equal to 0 as f of x greater than equal to minus 8 and less than equal to 8 e to the power minus 4. Now you can write range of h of x times range of f of x by 2 and take away 3. So range of h of x is now h of x greater than equal to minus 19 and less than equal to 16 e to the power minus 4 minus 3. So this is the range of h of x. I have also made lessons for lower levels. Check them out on my channel. To continue with this series, check the next video. See you in the next one.